Hi guys, welcome to Henry High School. I'm your teacher and your principal and everything else, Mrs. Henry. Welcome. Today we're going to talk about solving logarithmic equations. And we're going to talk about two different cases here. The first one is when log equals log. So when I have the bases are the same and the logs are equal, 5x plus 9 has to equal 6x. So I subtract 5x from both sides. 9 equals x. If I plug in 9 into both equations, 5 times 9 is 45, plus 9 is 56, and 6 times 9 is 50. Oh, 45 plus 9 is not 56. It's been a long day. 45 plus 9 is 6. 54. It's 54. Wow, I'm having a day. And 6 times 9 is 54 as well. So this equals, so there's no extraneous roots. So we're good. So now let's look at the next one. So I get log base 9 of 6 minus 3w equals log base 9 of negative 2w. So 6 minus 3w equals negative 2w. Add 3w to both sides, and 6 equals w. If I put in w here, I get negative 3 times 6 is negative 18, plus 6 is negative 12. And I cannot take the log of a negative, so this becomes no solution. So 6 becomes an extraneous root, which means it's a root that no longer makes sense in the context of the problem once we solve. Let's do 2 more of this type, and then we'll move on to our last part of the lesson. I get 3 log base 7 of 4 equals log base 7 of 4a minus 8. So this goes up in the exponent. So I get log base 7 of 4 to the third equals log base 7 of 4a minus 8. So I have 4 to the third equals 4a minus 8. And 4 to the third is 64 equals 4a minus 8. Add 8 to both sides. And I have 72 equals 4a. Divide both sides by 4. And x equals 18. When x equals 18, I have 18 times 4 is 72. Minus 8 is 64, and 4 to the third is 64, so 18 is my answer here. Ooh, except for this is a equals 18, not x. And our last problem of this type is going to say 1/2. My base here, 6. So this comes up, and I get the log base 6 of 25 to the 1/2 equals log base 6 of 23 minus 4w. So I have 25 to the 1/2 power equals 23 minus 4w. 5 equals 23 minus 4w. Subtract 23 from both sides, and I get negative 18 equals negative 4w. Divide by negative 4, and w equals 4.5. So 23 minus 4.5 times 4 is 18, so that becomes 5, and 25 to the 1/2 power is also 5. That works. None of those are extraneous. So now we have, let's do one more. Let's put one of these becoming a quadratic. That'll be lots of fun. So I have the log base 4 of m squared equals the log base 4 of minus 7m. So m squared equals 18 minus 7m. Now we have a quadratic here, so we have to put it in standard form before we factor. So m squared plus 7m minus 18 equals 0. And what two numbers multiplied together give me negative 18 and added together to give me positive 7? And this gives me m plus 9. M minus 2 equals 0. So m plus 9 equals 0. M equals negative 9. And m minus 2 equals 0. So m equals 2. So when I plug these in, I get negative 9 times negative 9 is 81. And negative 7 times negative 9 is 63. Plus 18 is 81. So that one works. And with my 2's, 2 squared is 4. 7 times 2 is 14. 18 minus 14 is 4. So that one works as well. Now we're going to look at the harder one. When a log equals a number. And let's solve some of these. So I have log base 2 of x minus 4 equals 6. So here, I have 2 to the 6th power equals x minus 4. 2 to the 6th power is 2, times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. 64 equals x minus 4. Add 4 to both sides. 68 equals x. And 68 minus 4 is 64. 2 to the 6th is 64. And it works. Let's try a couple more like these. I get the log of 2x plus the log of x minus 5 equals 2. So I have the log of 2x times x minus 5 equals 2. So 10 squared equals 2x times x minus 5. 100 equals 2x squared minus 10x. So I have 2x squared minus 10x minus 100 equals 0. So then I take out my GCF of 2, and I get x squared minus 5x minus 50. What numbers multiplied together give me negative 50 and added together to give me negative 5 is negative 10 and positive 5. So I'm going to move over here and finish my problem up. So x minus 10 equals 0. Add 10 to both sides. X equals 10. And x plus 5 equals 0. Subtract 5. X equals negative 5. So now if I plug in 10, 2 times 10 is 20. Times 5 is 100, and 10 squared is 100. That works. Now here, if I plug in negative 5, I get the log of negative 10. That's not true. Can't find the log of a negative number. That becomes extraneous. So we have our answer solved. Let's do one more. So I get the log base 6 of x plus 9 plus the log base 6 of x equals 2. So this becomes the log base 6 of x times x plus 9 equals 2. So 6 squared equals x times x plus 9. 36 equals x squared plus 9x. So if I put this in standard form, I get x squared plus 9x minus 36 equals 0. And what two numbers multiplied together give me negative 36 and add them together to get 9 is 12 and negative 3. So x plus 12 equals 0, x equals negative 12, and x minus 3 equals 0. So x equals 3. You can't find the log of negative 12. So that's extraneous. So my answer is 3. Let's check 3. 12 times 3 is 36, and 6 squared is 36, so it works. So now you've learned a little bit about solving logarithmic equations, and we'll be back with you again soon. Talk to you later. Have a good night.